Good afternoon, ladies and gentlemen. I'm surely not a scientist anymore. I'm working, as I have been told, as an advisor, but not in biological warfare. I hope I am advising the Foreign Office in issues related to the wide area of biological weapons and biological weapons defense and the influence on international treaties and negotiations on this issue. From my background, I have dealt with this area from a scientific side, being for 7 years during my military career the chief of the medical NBC defense in the Bundeswehr, and so from there I had a lot of impacts to continue later on this issue, to use my knowledge as well on a national basis for giving advice to ministries dealing with legislation on this, nationally as well, doing treaties internationally, as well supporting agencies that were deeply engaged in other issues like, for instance, UNSCOM in the Iraq and so on. Regrettably, the issue we are discussing this afternoon was not the primary agenda item of recommended scientific society and institutions in the last years. Regrettably, because I believe it should have been noticed earlier, what is the impact of science on the development of weapons, and as well what is the impact of the developments back on science. But with the events of the 11th of September and with the anthrax letter in the United States, I think since last year, the whole issue has got more public awareness, and that is a little bit surprising, because for people that have some more insight what was happening the last 10 years in global security environments, it was very clear that what happened on the 11th of September and with the anthrax letter was only the proof of the change of the global security environment. So the dilemma really is that we had to wait until it was proved what was already discussed in America for a long period and was labeled with the label of so-called asymmetric warfare, and the threats that especially were developed in the assessment to vulnerabilities of the United States society. I think now time is pressing the scientific community, because meanwhile steps have been taken that I think may have impacts on the scientific community by legislative acts or by discussions that have been started on how to limit the unimpeded access to scientific knowledge. And for this reason, I want to thank the organizers that they invited to discuss this issue, and especially to inviting me to talk to this issue today. As already mentioned before, I think the first time where people were concerned on the use of biological weapons that was coming up the end of the World War I, with the experience of the use of chemical agents in this war. And in 1925, the first time people gathered to look how to prevent that this can happen again. And the Geneva Convention of 1925 was also the first time where not only agreement was sought between states to prevent the use of poisonous substances, but also of bacteriological materials. One of the lessons that can be learned from the Geneva Convention and from the succeeding international agreements is that even the main contractors to this first convention 20 years later started large programs on biological weapons research and biological weapons programs. So one of the issues that enforced afterwards this was this mentioned use of biological weapons by Japan in World War II. And to state this clearly, at that time Japan was not a member of the Geneva Protocol, and they were not in breach of the protocol, so to say. But the effect was that the use of these biological weapons in China by Japan gave a big push to the programs that were operated as well in Western countries as well in the Soviet Union. And these programs ran to the end of the 60s, and at the end of the 60s, in the military communities of the countries running this program started a discussion if biological weapons are really worthwhile to be sorted in the inventories for further use. And at that time, people had the impression that the problems with biological weapons, as well with production, as well with storage, as well with the use, were so big that compared with the inventories on nuclear weapons and chemical weapons and the big conventional inventories of weapons they had, that the biological weapons don't make any more sense, and they made a decision to end their programs, and they started to negotiate the protocol, and that is the Biological Weapons Convention that was just mentioned, and this was signed in 1972. And this convention entered into force in 1975, but it took only 4 to 5 years, and then rumors started that one of the main contractors and one of the depositories, so to say, the mother of this convention, the Soviet Union, was in breach of this convention. And since then, we have history telling us that the number of states that doing research or even production of biological weapons is increasing. Why are biological weapons today maybe of more interest than they have been in the end of the 60s? I think there are two reasons. One reason is scientific reason. The progress, I think, of biotechnology and the biosciences was so tremendous that the insights you can take, what you can do with this type of agents, gave, I think, new thinking that it's useful to take them. The second is that the technology for production and storage was dramatically improved in addition. And it was very clear that the investment in this type of programs in money was much more cheaper for a lot of countries than investing in chemical or in nuclear weapons. And the second point that has nothing to do with science, the number of countries that expressed concerns that their political as well as their strategic aims could be achieved no more with conventional weapons, but only with unconventional weapons increased, and this especially versus an overwhelming US conventional military power. And to make this very clear and not to misunderstand me, what I described, that is only the description of reality. That is not an excuse for any state to act in breach of the Biological Weapon Convention. The development of science and technology is a recurrent agenda item of the so-called review conferences to the Biological Weapons Convention that take part every 5 years. And together with the issue of proliferation of dual-use equipment, dual-use agents to possible or suspected biological weapon states, this is the main reason why in 1991 the states parties to the convention started a process to strengthen the biological weapons, which was a convention from 1972, and at that time it was not usual that an international arms control agreement had a mechanism for verification if everybody is in compliance with the convention or not. And I think John Walker will take up this issue and will introduce a little bit more on these efforts that started then. Before I approach a little bit deeper on the advances in science and technology, I want to go back a step and we'll go to the convention. And I think because it's necessary to understand how the convention defines what is a biological weapon. And the definition you will hear now is a definition you normally also find in national legislation, for instance, also in German national legislation and in most of the legislation in European and Western countries. And it's interesting because from the definition you can see that what you are doing is setting a lot of your activities on risk legally. And I will read what the definition says. The definition says in Article 1 of the Convention, each state party to this convention undertakes never in any circumstances to develop, produce, stockpile, or otherwise acquire or retain, first, microbial or other biological agents, or toxins, whatever the original method of production, of types and in quantities that have no justification for prophylactic, protective, or other peaceful purposes. And secondly, weapons, equipment, or means of delivery designed to use such agents or toxins for hostile purpose or in armed conflict. The charm of this definition is that it has not become outdated since it was implemented in 1972. All technological and scientific developments didn't overrule up to date this definition. And this definition does not describe in technical terms what a weapon really is. It only defines indirectly what is a permitted purpose to use certain type of organisms or biological materials. So let's open a lot for interpretation what really is a weapon. And so it can mean that possessing a special organism of concern where nobody can explain why you possess it is having a biological weapon, as well in national legislation what is prohibited, or in the context of the treaty. Or if you have a quantity of some type of agent where you cannot explain that you need to have it for your research activities. So the next is, if you look for the dissemination part, if you have an aerosol generator where you can produce an aerosol with inhalable particles of biological materials, and you cannot justify that you need to have it. In principle, somebody can say you are possessing a biological weapon. So this is done deliberately in definition, because definitions in this type of international treaties always want to cover first a wide area, and secondly, they are written in a way that technological and scientific developments that come up and are related to this are covered over a long distance. And this definition exactly does this. In today's public discussion on risks arising from the advances in science and technology in the context of biological weapons are primarily tied up with not scientific issues. The first word is terrorism. The second is production of microorganisms, and then if I would be a politician, I would not add in any garage, and that is what you normally hear if people talking on this. And the third issue, that is the spread of knowledge on genetic manipulation work. And without playing down the risks of terrorism, but I think we can state that the lonesome terrorist or a small group of terrorists that are really not the main issue of concerns. When we look back the last 2 decades, we can only identify 5 events of authenticated deliberate release of harmful biological materials. The focus in the international discussion on biological weapons is more on states, and states that invest in facilities, in equipment, in manpower and knowledge to gain access to biological weapon information or biological materials, and which have the financial resources and the time to acquire technologies and the upcoming scientific knowledge. Some subsume states also to be terrorists. I have not a problem with this. This is a question of terminology, what do you want to call a terrorist. But if you go and you look on what are the risks, I think there's a big difference if you look on a lonesome terrorist or a small group or on a state, because the investments that you have to do on getting access and use of new technologies makes a lot of difference and between a single or a group terrorist and state terrorism. A large number of microorganisms and toxins can be used as biological weapons, and a lot of lists are out of on the market, which some of them are legally binding. For instance, a list that is included in the European legislation on dual-use export controls. We have lists in recommendation papers on the treatment of possible biological weapons infections by the WHO. There are lists from NATO. There are lists for export control from the so-called Australia group, and there are national lists in national legislation. From list to list, we're talking on 30 to 60 different agents, and cis agents normally are used for attacking, and that's going beyond what was discussed, I think, up to now in this room, not only infecting people, but also infecting animals and infecting plants. And I think the last two issues are especially concerns that are now coming more and more up from developing countries, which, if they discuss on biological weapons, have more concerns on the last two targets than on humans. And if you look for the type of agents, you can see that the range is going from non-contagious agents like anthrax to highly contagious agents like smallpox or very toxic substances like botulinum toxin. As microorganisms and viruses normally cannot penetrate intact skin, we also have a look on the type of dissemination, and the preferred type of dissemination of biological weapons is generating an aerosol in inhalable particle size. And for this reason, I think if you look on biological weapons, you have not only to look on the agents, you also have to look on the technologies, how to disseminate this. The existing lists, which are normally produced for export control purposes, are more or less only a historic description of our knowledge. And even if they are updated time to time, and even the inclusion of any type of microorganism to which a gene sequence is introduced that is coding for virulence or for pathogenicity factors of listed threat agents, or in which is introduced the gene sequence for expression of a listed toxin, is still a step behind what really are the risks we have to deal with if we talk in future on biological weapons issues. And we are completely missing in this list any type of substances which we discussed today as so-called bioregulatory substances, and we are missing also any type of agent which are discussed now coming from our experience on research in biodegradation and which may be used as anti-material weapons. Coming to the points where now science coming in this business, and maybe you heard already a lot of that one of the big risks may be that the generation of antibiotic-resistant agents is a big issue. I'm not so convinced personally that is really a big problem. Firstly, that's a technology that cannot controlled anyway, because marking organisms by antibiotic-resistant markers in genetic work is a day-to-day issue what you're doing. It's a question otherwise if you really can make stable clones which are resistant to all known antibiotics. And the other question is it necessary to do so? Our capabilities to detect the dissemination of infection agents in an early state are very, very limited. We have no real-time detection capabilities. That is different to chemical weapons. In chemical weapons areas, we have really the technology to detect real-time when an agent is released. In the biological field, we are still missing this capability. We have to wait until the agent sets out the disease and we see symptoms. And normally, we only can identify something if we have a bigger number of casualties with an unusual disease appearing in the doctor's offices. And an additional thing is by the mode how biological weapons are disseminated, and that is not the normal mode how most of these infections are going on in humans. You inhale this and you get a different picture of symptoms, and it's difficult in the first days really to decide what type of infections people have got. So we know exactly that we have a delay in time to react on this, and we have a lot of agents, or some agents, where even if we start a reaction by antibiotic treatment, we will be too late. Look for anthrax. Anthrax has a mechanism that is based on toxic substance, and most of the patients that will be treated with antibiotics will start treatment too late because you cannot overrule the toxic mechanism. You only can influence the growth of the organism in the body. But if you start too late, then maybe it's too late and you have no chance anymore to have treatment properly done. So what is the usual way how people try to prevent against biological weapons? And the usual way for prevention is vaccination. But do we have vaccines for this type of agents? And to state it clearly, we're missing for most of the agents which we are discussing as biological threat agents, vaccines. Either we don't have them, or if we have some, they are not licensed, or they are on an investigational status, or even we have taken political decision not to use them. For instance, if you look on the discussion today coming back on smallpox vaccine, and you look, we have in none of the Western countries, when we started a discussion on re-entering the use of smallpox vaccine, a licensed smallpox vaccine. We had one, but we didn't use it for a long time, and by this we lost the license of the vaccine, because normally for a drug or for a vaccine, you have to go in a circle for every 5 years to renew your license, and if you don't use it anymore, you lose your license. We have made political decisions, for instance, not to use foot and mouth disease vaccine for animals. And the only reason is an economic reason, because if you vaccinate cattle against foot and mouth disease, you cannot export your meat to the United States. Because they say you cannot decide if it's a normal infection or it's, the antibodies are coming from vaccination. So the EU made a decision, no more vaccination against foot and mouth disease in Europe. We have similar examples to other animal productions in the European Union. Hog cholera, Newcastle disease. We have vaccines, we don't use them for economic reasons. Coming back to the spectrum of agents we are dealing with, I think it's very clear that with 30 to 60 agents, we have no chance to develop vaccines to cover each of this type of agents which we are discussing. And then there's another issue. Most of the agents we are discussing are agents which normally don't affect humans. Most of them are zoonotic agents. So they normally infect only animals, and only in very high doses or by inhalation in high doses, they can cause a disease in humans. And that was a deliberate decision done when the countries developed biological weapons. They were for military use. You wanted to go for a tactical purpose. You don't want to have an agent that spreads worldwide. So you had selected the zoonotic agents with a high concentration by inhalation, affect only the target area where you disseminate it, and the infection is not running out of this area. So, and next thing is, even if you have vaccines for this, we don't really know if they protect very well human beings, because we can develop this vaccine in animals. We can challenge the protection level in animals, but the diseases are so rare in humans that we never know that if we use them in humans, if they really protect, if there's a massive attack with inhalable doses that maybe normally some 5, 10-fold infective doses what you normally expect for an infection. So I think the problem can really not be solved in future by developing more vaccines on this issue. And the question really is if more money should be spent in the area of doing more research in improving unspecific immune response on these issues. In addition, we know that the vaccine can be overruled. And for instance, the Russians, which surely have, I think, one of the best vaccines against anthrax, they have tested their vaccine if you can genetically manipulate the anthrax germs in a way that you can overrule the protection by their own vaccine. And they have introduced, for instance, the gene sequence from Bacillus cereus into Bacillus anthracis, and it worked. The vaccine doesn't protect anymore in humans. So the second example, I can tell you how you can run in problems. I think that is a well-known example because it was discussed last year in Science widely. This was this Australian mousepox research event. If you don't know, very simple, the Australian had a problem with mouse populations. So there were some researchers that, people try to make a vaccine that prevents the embedding of eggs in the mouse, so they cannot produce new populations of mice. So, and they tried to make this vaccine based on mousepox virus, because in Australia there are a lot big populations of mice which genetically are resistant to mousepox virus. So they used the mousepox virus to add the agent that is against the embedding of the egg. And in addition, because they believed it is helpful for this, introduced a gene sequence that also is expressing EL4, and the result was all mice died. Even the ones they used that were genetically resistant to mousepox infection. And this was the first time, I think, where I know, in science, where a government came in and debated with the scientists if this result should be published or not. And at the end, the Australian government made a decision to publish this. And I will come back to this, or you will see how this will influence other decisions afterwards. But recently we just learned that it's not necessary to have a living organism to create biological weapons. I think you all have read that researchers in the United States have created the poliovirus from the scratch, from the published DNA sequence. They even bought some of the DNA snippets they used for creating this agent from companies which produce DNA snippets on order. And they proved that this polio agent really is active in cells and creates the same infection as a real poliovirus. And you know, and you may have read that in the United States a discussion started if that was useful to publish this, but meanwhile people discussing if the next agent you can do this maybe Ebola, and people say, and you can expect, I think this is a challenge to scientists not to go only to small viruses, but to go one day on bigger viruses. And there's a discussion if the production of viruses from the scratch, especially polio, may have an impact on the WHO program to eradicate polio, and maybe also to terminate one day the polio vaccination. Maybe for polio that's not a big issue because polio is not such an interesting biological weapons agent. But there was already once in history done a decision after eradication of an agent to stop a vaccination, which today may prove to have been wrong. And that was the decision to terminate smallpox vaccination after the eradication of smallpox. Surely the vaccine we have today is very bad, has a lot of side effects, and it made sense at that time not to continue vaccination after you have decided there's no more smallpox existing. But today we have a discussion if really the two official WHO repositories for smallpox for variola agents, that is CDC in Atlanta and the vector in Kosovo in Russia, are really the only possessors of smallpox viruses. You can question if what is out in the world is true or not, that other possesses, but there's no debate on that smallpox, to our understanding, is from the biological weapon agents discussed, the one with which is the most infectious and will create the most health risks. But we know also that the orthopox viruses in their genome structure are all very similar. And we know from history that the vaccine which we had didn't only protect against the smallpox, but also to other orthopox virus infections, because we have seen after the termination of the vaccination that the infections, especially in Africa, on non-vaccinated young people with monkeypox appeared. And we had other indications that the vaccine could protect against other orthopox viruses. And now, in the context of the polio issue, you could see that in the United States, somebody has now started for a very legitimate purpose to re-engineer sequences that are published from smallpox in vaccinia virus. And we have published the genome completely of 3 strains of variola viruses. The complete gene sequence of another 8 variola viruses is under discussion to be published. And you see, you don't need to go creating something from scratch here. You take an existing orthopox viruses, you compare the published gene sequences, and you see where's the difference, and then you try what you have to introduce from smallpox and on orthopox viruses to get the same virus infectivity or which you can create with smallpox. So I think it's necessary today to discuss, and there's work underway, to create newer and better smallpox vaccines. By the way, I think one of the side effects of this will be that DNA sequences and DNA synthesizers will be the next equipment issues that will be put on export control lists. Yeah, such life. And it's not new. We discussed this already. I think John Walker can do this in Geneva for years before we dropped the protocol. Another interesting issue is from science, I think, is if you look on studies on gene expression and on the possibilities today you have with gene microarrays and with protein chips to get a better insight how the genome and the proteome react. And I think that is an interesting issue because it will change, I think, a lot of approaches in medicine, going away from symptomatic cure and treatment to look on the molecular level how you can step in and can do better things in medicine. But there are also risks if you get better insights. You know, you can introduce the genome of a virus in the genome of a possible victim. But that's not all. But we know exactly now that we have also mechanisms already tested to switch on such type of insertions and switch off. So that is a risk in addition that is coming up by more knowledge on what is going on in cells and in the genome. And we get more and more substances which from the pharmaceutical science which are what we call bioregulatory substances. If you go on the internet pages of PhRMA, the United States Association of Pharmaceutical Industry, or in Germany on the internet page of the Verband der Forschenden Arzneimittelhersteller or DECHEMA, you can see which so-called bioengineered or biotech drugs are either in the pipeline or on the market. In the United States, presently, PhRMA, I think, has around about 350 different biotech pipeline products listed. In Europe and in Germany, I think it's around about 100 substances. Most of them are connected with research in treatment of cancer. But we see an increasing number of substances that are influencing the neural system, the blood pressure control, and the immune system. And if you go back and look on literature, you can see that there's already published the use of a substance B, that is a tachykinin, which is used as a biological weapons and how you can use it. And we can see that a lot of more substances are coming up that can influence exactly the target areas which, from a weapon perspective in humans or in animals or in plants, are of interest. By the way, the chip technology also has an impact on chemical weapons, because with the chip technology, you can screen a lot of number of chemical substances going in tens of thousands of a day, where you get a whole pattern of reaction on proteins, and you can easily select which are very toxic and which may be used for new chemical weapons. In addition, I think what is something that is a little bit going more in future, that is the use of information technology, and I think everybody agrees with that the progress in biosciences would not have been possible with the impact or with the use of information technology. I think the storage, comparison, and processing and integration of biological data play a central role today in science. But we are not collecting only data on molecular and cell levels. We are today using information technology to collect a lot of data that are coming from medicine on diseases. We are collecting data in health insurances, and we collect commercially data. There's a company in the United States, if you go to their website, they are proud to announce that they have data sets of 20 million patients from the United States, collecting every day tens of thousands data files from hospitals, practitioners, and pharmacies. And they process this data and they sell this data to pharmaceutical companies for drug research. And these data are related to sex, to age, to race, to individual behavior. We use information technology to screening of the genome of whole countries. The Iceland project, I think you know all. So if you now look forward and see what we are collecting on information on diseases related to persons, the group of persons, and you'll see what informations we can collect from molecular biology, and you use this, then you easily can say, I think that the theory of ethnic weapons comes more and more true and is going even beyond ethnic weapons at one day. In the context of biological weapons, as I told you, I think you also have to take into account the issue of the dissemination technique. I don't want to go too deep in this, but the technologies that were used formerly in offensive programs, especially in production, stabilization, storage, and dissemination, I think they have also made tremendous increases. If you see that we have today production capabilities with high cell densities, we have continuous production process in industry, we have increased our possibilities of tissue and cell growth techniques for large-scale production of viruses. And we even discussing now on cell-free media. And in addition, we use freeze-drying, micro-encapsulation, and we knew that there was technology available to stabilize aerosols by additives that you can prevent clotting of the particles. And all these technologies today are no more related to biological weapons. All these processes today in industry are used in large scale for any type of products, nothing to do with biological issues. And that is one of the concerns we have also to take into account, that the fusion of the large-scale product and use of these technologies with the progress in the biological field may create new risks. We use this type of technologies also today in the application of drugs. More and more aerosol applicated drugs are coming on. A lot of vaccination in the agricultural area for animals is done by aerosol application of vaccines. And we see that for consumer compliance, the number of drugs that are delivered through the skin is increasing. And there's a lot of research done how to make it possible even to bring large molecules through the skin in the body. So, in addition, bioscience, I think, already has left academia decades ago. We have large industries in this, and the industries are no more restricted to the industrial countries. You can see that in China, in Cuba, Iran, in India, you have already biotech drugs on the market, even if they are compared with the number what we have in Europe, they are limited, but they have, in principle, access to any type of technology we use too. And there's no reason not to give them these technologies as long as they use this for peaceful purposes. But there's one problem. What I discussed all up to now, I always talked deliberately on risks. But I think we are now in an area where people try to change risks in threats. And risks become a threat if you tie up what is your assessment of possibilities with facts coming from intelligence, from political decisions, by telling people have bad intentions. But there's I think presently in the Western world, feeling and that is a perception that we really are now exposed to a biological threat and no more discussing risks. And what you can see is, and that already has started to make it very clear too, even if it was not realized, that it has started before the 11th of September, that there was a dramatic increase of investments in biodefense research, in biodefense preparedness, and also some deliberations to increase legislation on this. If you look for biodefense research, you normally can say that all what we have been done in the past was closely keeping pace with the progress in science and technology. There were presently in the main actors in this field, two routes followed. One was the development of vaccine, and the other issue was the development of rapid detection systems. I don't want to repeat what I have said on the vaccines. I think we cannot fill this gap by vaccines and creating by this prevention that really minimizes the risks. But if you look on the detection side, for the last 20 years, we have done tremendous progress because if you see what we have on hand with tools today with monoclonal antibody, high specific detection system, what we can do with gene probes and with PCR, we have brought down detection times from days to hours or even to minutes. But we are still away from real-time detection. And so for this reason, it needs some more work to have been done, and we know exactly how our detection systems using antibodies and using markers can be overturned by genetic manipulation if people know what antibodies and what markers we use in our detection systems. And the second issue is biodefense preparedness. That is something different. And biodefense preparedness is an issue which is really questionable if you convince somebody who wants to run a biological weapons program as a state, if he will refrain because you are better prepared on an operational basis how to handle casualties they can create. And there's a second issue that belongs for me to biodefense preparedness, that is damage avoidance. And damage avoidance is really do we have preventive means that damage will not come up? Can we detect earlier? And that is exactly the technical tools we are still missing on this. So last but not least, with the loopholes we have, people now are looking back on legislation. How can we close loopholes by having better laws and regulations to govern the whole area of biosciences? In principle, that is nothing new. We have legislation on handling microorganisms in all Western countries for decades. Normally, in our countries, everybody is only allowed to work with microorganisms if he has some expertise with this. We have regulations how to prevent release of agents to the environment or to infect humans or animals or plants. And if you see what when the genetic revolution started, at first controlled, more or less self-controlled by academia, when it went on the level of commercialization, it was easily turned in most of the Western countries in very restrictive legislation and regulations. We have in a EU regulation dealing with the use of genetic modification work in containment as well as for open air release. But even in the Western countries, some countries that don't have regulations, they still are only relying on self-regulating mechanisms. But this is only control for domestic purposes. So we have created also legislation to control countries of concern by export controls. We do this nationally, we do it by EU legislation, and we do it by informal exchange, what we call like-minded countries, countries which have the same concerns that the proliferation of technologies and of materials may create problems. And one of these like-minded groups is a so-called Australia group, which combines normally all the industrial Western countries. And now, we have seen after the 11th of September that Western countries have started to improve their national legislation. We have seen new legislation in France, the so-called Kouchner decree. We have seen in the United States some legislation. The most impressive one is the United States Patriot Act. What Patriot means, in this, I have to read this, provide tools required to intercept and obstruct terrorism act. And we have seen new legislation in the United Kingdom, the Anti-Terrorism Crime and Security Bill. And this legislation not only regulate the access physically to biological materials, they now bring in a new nuance of what should be controlled. And this new nuance is related with an issue that was taken up in the Australia group. And this means control of intangible transfer of knowledge. And control of intangible transfer of knowledge means that you don't have to give something on paper to someone to do an illegal act. It means if you communicate information knowingly that your counterpart may misuse this, then this will be against law and you can be sentenced for this. And I don't know if you have followed the discussion in the United States. In the United States, this is a big issue now in public discussion and in academia. And you may have also read that in the United States, the first student was sentenced because he didn't destroy a strain which he didn't need anymore for his research, because the new law source says you only are allowed to possess what you really need for your work. So if you store something which you don't need for your work and it's on the list, then you can be sentenced for this. And we have now in Europe, I think with the laws in UK, also a technical base to start this discussion, and I think we can see that the discussion from the United States will spill over very shortly to Europe. And we had a discussion like this in Germany once. That was end of the 80s, when we had the Raptor case in Germany improved the national legislation on export controls and on the War Weapons Control Act. And in the legislation process, the representatives from scientific community had to comment on the draft of the law. And to my surprise, at that time, they didn't reject what was planned to limit publication of scientific findings. It was later in the process of decision by the representatives of the ministries which wrote this improvement of the law to say that the impact of restricting publications, and in addition, the second issue, and that's coming back up again here, to restrict access of students from some countries to biosciences, has a more negative impact than losing transparency what's going on in science and where the risks are. And we are exactly as now on this point where I think we'll have to come back on this discussion again. And I think it's worthwhile for the academia to look very closely what are good arguments to prevent that we are going back on a row where the government or the state really makes decisions that impacts science in a way that you lose a lot of what I think is normally what you want to protect, your freedom. And the only way to prevent this, I think, to start a discussion under yourself and to find self-control mechanism. And one of the self-control mechanisms is, I think, if you come to the point where you publish something, you have to decide yourself if your result is worthwhile to be published, and or if it's better not to publish it because the risks are higher than the progress of humankind you can achieve with this result. And I think the worst thing that can happen is that a yet non-identified agency makes a decision for you if you are allowed to publish or not, makes a decision who will get access to what you have published, makes a decision who may use the result for his own studies. And I only can say we are not at the point that it will happen tomorrow or the day after tomorrow. But if the discussion is going on similar to the United States, you have to be aware that you have to be prepared to give answer to the solution. Otherwise, other people will do this for you in a way where you don't want to prefer that it will happen. Thank you so much for your attention.